In the previous video, we've seen that when you differentiate some sort of constant times e to the power of x, it really becomes itself. So, for example, 7 e to the power of x. If you differentiate that, it will give you 7e to the power of x. If you have a constant, let's say I don't know 5e to the power of x. If you differentiate this here, it will become 5e to the power of x. Okay, so now in this video we're going to investigate how you would go about differentiating. Let's say now the constant is up here. So for example, how would you go about differentiating e to the power of 5x? So up here it was 5e to the power of x. So the constant is in front of the e. So now the constant is up here. Okay, well anyway, so in this video we're going to try and find a way of differentiating this here. Okay, so let's take as an example, take it as 5. So here we've got e to the power of 5x. So our normal routine is to add a tiny bit amount on here. So to add a tiny bit amount on this thing here, and then take. So that's adding a tiny h on top of it, and then take away the original, taking away the original here. So that's taking away the original, divided by h, and then take the limit as h tends to 0. And then this bit here, if you multiply this out here, okay, this times this here, it will then give you e 5x plus 5h. Okay, well whenever you have a plus somewhere in between here, then you can think of that as being 5 e to the power of 5x times e to the power of 5h. Okay, so remember xa times xb, that's the same as x a plus b. Yeah, so well anyway, that will then give you this, which is this bit here. Okay, and then this bit here is this bit here. So well anyway, this whole thing here becomes this thing here. Okay, and then notice that here you've got a block. Well, that this is in common, this is in common. You can factor out e to the power of 5x. So factor it out. That will then give you this times this thing here. Okay, hang on. That will then give you this thing here. So now remember, one of the laws on limits is the age that's changing about. It's the age that we're moving about. This thing here is just a constant. This thing here is just a constant, so we can actually take it out here. It doesn't move. It is the age that's moving. So for example, if you have a graph like this here, x is somewhere here, and then h, this is your h. Okay, h is moving about. H is moving about. This thing here doesn't change. Okay, this thing here doesn't change. It's the h that's moving about. So we can actually take it out here. So that will then give us this thing here. Now let's just switch the two around. So move this one over here, and this one move it over here. So it looks like this. Okay, so when you differentiate e to the power of 5x here, it's going to be some sort of number in front, and then times e to the power of 5x. Now let's translate this into our graph. So we developed this technique before in one of the earlier videos. So we want to ultimately find the limits of this here. But to find the limit, we can translate this limit problem into a graph problem. So translate it into a graph problem. Get a graph plotter and plot this. And then, as h tends to 0, that's the equivalent of us moving x towards 0. So, well, anyway, we want to find out this. Translate it to a graph problem, which is this thing here. Get a graph plotter and plot this. That will then give you this thing here. Okay, that will then give you this thing here. You see, dead on zero is undefined. But the thing is, you finding out the limit of this here as h tends to 0, you finding out this is the same as you getting x to move towards 0. for this one here. So if you get a graph plotter and plot it, it will give you this. So that's the same as you heading towards 0 here. That's the same as you starting here and heading towards 0 here. Heading towards 0 here. So you can see it is heading towards, well, 4 is here, 6 is here. It seems like a 5 here. So when, well, you see this limit here, this box here is really 5. The limit is 5. So when you differentiate this, it becomes 5, and then this block here, e to the power of what? So when you differentiate it, it becomes 5e to the power of 5 x. So it seems like this thing here gets moved down to here. Okay. So here's another approach here. Suppose you want to differentiate a constant in front of the x. So let's imagine this as being a bubble here. So let w here equals 3 to the power of x here, and use a chain rule. So starting from here, we would let w equals 3x. That's like us differentiating this. Now when you differentiate this, this would be e to the power of w, but don't forget w is a function of x, so it's really you using the chain rule here. Now we've got to times it by dw by dx here. So that will be, this is us using the chain rule here. So this will be times 3. Okay, so that's the same as 3e to the power of w. So which is 3e to the power of, 3e to the power of w. But don't forget w here is 3x here. So that's w there. We can change it to 3x here. So look at this. When you differentiate this, it gives you this. Okay, hang on. Let me just start again here. So you want to differentiate this. So hang on. You want to differentiate this, e to the power of 3x here. So imagine this as being the bubble here. So differentiate this, d by dx of e to the bubble would be, well, differentiate this. This would be e to the power of the bubble, and then times d bubble by dx, if that makes sense. So you've got to differentiate the bubble itself, because this bubble here is a function of x. Don't forget there's a 3x in here. So when you differentiate this here, it will be a 3. It's really you using the chain rule. So this will be 3e, and then don't forget the bubble is 3x here. So that gives you this. So again, it seems like when you differentiate this, the 3 here gets moved down to here. Or you can take a different approach. Use the product rule here. So if you want to differentiate this, visualize it as this thing here. So you've got this thing times this thing. Remember, if you have x to the power of a times x to the power of b, then these two gets added together. So look, you can see x plus x is 2x. So we can start from here and then get to here. Now use the product rule here. The product rule, differentiate this, leave this the same. Okay, and then later on differentiate this and then leave this the same. That's the product rule. So remember, the product rule is differentiate this, leave this the same, and then plus leave this the same, differentiate this. Okay, so let's do the product rule here. Differentiate this, that will give you e to the power of x, and then leave this the same. So that will be e that would be e to the power of x, and then plus, now leave this the same, which is e to the power of x, and then differentiate this, which is this itself. That's the whole beauty of us inventing that number e, whatever that number is, because when we come to differentiate it, it's so simple. Well, anyway, this thing times with this thing, that would be e to the power of 2x plus e to the power of 2x over here, because merge this with this, that will give you this. Now that's like you saying one elephant plus another elephant, because these are pretty much the same. One elephant plus one elephant, that equals two elephants, two exactly the same thing. Two exactly the same thing here. Okay, so when you differentiate this, it seems like you move this out here. So in general, if you want to differentiate this thing here, if you want to differentiate this thing here, you well, move this out here. So yeah, that will then give you this. Okay.